We're going to talk about Google's new initiative called AIY, which is sort of teaching people how to work with artificial intelligence on their own, kind of on a budget, on a small scale, but enough to get into the technology and see that you can actually do some very powerful stuff. So, so today we're going to build two different AI devices, and I'll show you how to do that. And then I encourage you to also see if you can acquire some of this hardware and do it yourself. So, so I want to start with a brief introduction to a very famous AI.
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
I think you know what the problem is just as well as I do.
What are you talking about, Hal?
This mission is too important for me to allow you to jeopardize it.
I don't know what you're talking about, Hal.
I know that you and Frank were planning to disconnect me, and I'm afraid that's something I cannot allow to happen.
Okay, so so you get the idea. I don't know how many know that film, but in case you didn't, that's Space Odyssey 2001. And in that film, the AI, well, things go bad in the end for the AI. So, so we're not going to do anything quite that ambitious, but it is, you know, we're going to at least dabble in the technology. So Google last year created the first of these kits called the Voice Kit, which is you're basically building a small connected device with a Raspberry Pi to work with the voice interfaces and the AI associated with that. And this year they came out with a new and improved version of 2.0, and they also came out with something else called the Vision Kit, which is sort of the same idea, but in this case it works with the Raspberry Pi camera. So, so in both cases they're pairing a small bit of hardware together with their APIs and some of their software, and it allows you to create very powerful things for not a lot of money and not a lot of programming. It's a great entry into this field. So, so those are the two kits. The Voice Kit in its 2.0 form goes for about $50, and that includes, unlike the first one, this includes the Raspberry Pi, includes the SD card. The SD card is already preloaded with Raspbian, which is the operating system. So it's a much better way to kind of get started. With the 1.0 kit, you could do it. You just need to be a little better with Raspberry Pi and you know, imaging a small SD card and things like that, which can trip up some people. Somebody from Google had mentioned that they want to be able to go into a middle school and in 2 hours have people, you know, up and running with these kits. So they didn't have, so they got rid of the more complex imaging process. They don't have any soldering, you know, all things that are good for makers to learn, but I think they wanted to also sort of make it seamless for somebody to get up and running quickly. So that's what's really great about these kits, particularly the newer version of the Voice Kit. So, so that said, these are what the kits look like. On the left is the voice, on the right is the vision. You get everything you need. They come well packaged. They have really nice instructions online. And I think they recommend anybody over 14, but I'm guessing if you have a really bright 10-year-old, they probably would be able to do this. But it's great for adults too, and there's no age limit as I'm proving. So so let me talk for a minute about microcontrollers in general. For those that don't know, a microcontroller is just a very small computer. It's often used in what we call embedded applications. So that would be without a monitor, without a keyboard and a mouse. but just embedded inside your car or bicycle or any small device. Your microwave has one. These things are everywhere. And the one that you see at the top of the screen is an Arduino, which was one of the first really popular microcontrollers for people to for hobbyists to work with. This one goes for about 20 bucks. It is actually something called open source hardware. I think everybody here is probably familiar with open source software, but it's the same concept. The designs for the circuit boards are open. People are welcome to improve upon the design and contribute and make alternate versions of an Arduino. So the idea is to get people playing with it and trying it and using it, and there is also usually with open source some cost pressure that keeps the price of these things very low. The one, as I said, that you're looking at is an Arduino Uno, which is about 20 bucks, but you can get a cheap knockoff clone from China for 5 bucks, and they work just fine. I usually like to get the real Arduinos just because I like to support the organization a little bit, but the clones that I've used have worked fine for, as I said, even 5 bucks. The one to the bottom of it is a Raspberry Pi, for those that don't know. This is doing similar things, but it's more sophisticated. It has greater capability, but the idea is the same. It's a small embedded controller that takes a lot of inputs. These can be sensors, these can be buttons, these can be cameras, and it takes in all that input, interprets the input. You can have algorithms running against that input, and then usually creates some kind of output. Drives a monitor, drives an LED or an LED matrix, drives motors that control robotic arms, all kinds of things, right? A microcontroller in a car could control the braking system. So the one other thing to understand about the difference between these two, the Arduino tends to be a little simpler. Usually it's just running one program. So you write a program in C usually, or C++, and the Arduino just runs that one thing. It's very dedicated. It's real time. It's very responsive. It's not doing a lot of things except that one program that you've written. So some people prefer it because it's simpler and more dedicated, more responsive. But by contrast, the Raspberry Pi is running full-blown operating system. It's pretty amazing. It's running a pretty sort of a stripped down version of Linux, but it's called the most common version that people use is called Raspbian, and but it's full-blown Linux. It's pretty amazing. The guy that came up with the concept of Raspberry Pi was a computer science teacher in England. His name escapes me, but he enjoyed hacking with hardware when he was young, working with soldering irons and building interfaces onto that computer, and he appreciated the spirit of the early computer movement. Had a lot of hackers like this that were really digging in, really working directly with the hardware in addition to the software. But as computers got more sophisticated and more expensive, he found that a lot of his students were sort of afraid to open up their, let's say, $1,000 computer and start to muck around with a soldering iron. So he decided to develop the Raspberry Pi as a very low-cost, sort of stripped-down version of a computer, so that people would feel comfortable messing with a soldering iron and having it drive motors, so that if you mess something up, you're not out that much. So it's low risk hacking. And the Raspberry Pi that you're looking at right now on the lower left is about $30, and it's quad core. It actually has quite a bit of power to it. It's got an HDMI port, so it can drive a full, big screen HD TV. Over here, it's got 4 different serial ports, so you can obviously connect in keyboard, mouse, and all kinds of standard USB peripherals. It's got Ethernet if you want to connect directly to a network, but it's also got built-in Wi-Fi, built-in Bluetooth, built-in extra camera ports, so all kinds of things. And in addition, it does what all microcontrollers have to do. It also has what are called GPIOs, general purpose I/O pins. So if you look at the header up here, it has 40 pins here, and they can be programmed to be either inputs or outputs. So again, you can hook up a sensor to one of these pins, and you can hook up motors to a couple of these other pins. And some applications have lots of inputs and very little output. Some have lots of output and very little input. You decide. You can program it. It's highly configurable. The Arduino as well has these general purpose I/O pins. So again, that's sort of the core of what a microcontroller is and what it does. But in the case of the Raspberry Pi, you've also got a full-blown Linux operating system in addition. So the one warning with a full operating system, it's doing all kinds of other things. So it's not exactly quite as responsive as the Arduino might be. So for instance, you wouldn't use this for something that really required a true real-time operating system, like let's say a braking system in a car, or medical equipment, or things where you just can't go off for 100 milliseconds every now and then to do garbage collection or service a cron job or something else. But that said, plenty of applications for the Raspberry Pi. It can do an amazing array of things. I think for those that haven't started to play with it yet, it's a great little device and cheap, and so I highly recommend getting started with the Raspberry Pi. And finally, on the right is another version of the Raspberry Pi. This one's called the Pi Zero, and it made enormous headlines when it came out, maybe 2 or 3 years ago, because the goal of the project was to make a Raspberry Pi that you could do for $5, or somewhere between $5 and $10. I think right now they're about 10, and I don't know that you can get an official Raspberry Pi in quantity at that price, but you can certainly get some clone of it in that price. So the idea is super low cost, super small, and yet it still has tremendous capability. Here again, you see the GPIO ports. You've got serial ports. You've got these are camera ports. So it pretty much does a lot of what the big one does. Not quite the same processing power. So if you have something that's CPU intensive, you might want to stick with the big one. The other reason people like the large ones is they tend to be easier to prototype with. So let me move to the next slide, and then I'll show you what I mean. This is as I said, Arduino is open source. This is just to show you some of the variations. These are all Arduinos. This one, I believe, I think this is a nano, but it might even be, I think there's one smaller than a nano. And as you can see next to the guitar pick, it's tiny. And yet it has a small serial port, so you can download your software to it. And it's got, looks like about 10 I/O ports. So again, sensors, motors, however you choose to configure it. This one down here is a very interesting variation, also an Arduino, called a LilyPad. And the concept here was to have a microcontroller that you could sew into clothing. So this is part of what's called the wearables industry. So people sew this thing into their sweatshirt, and then they can have LEDs. You could have, for instance, an LED around your heart, and then another sensor that monitored your heart rate, and your sweatshirt could blink to your actual heart rate, or give your vitals. All kinds of crazy things you could do. And this is a very tiny version of the same thing with just a couple LEDs that blink in certain patterns. So it's a kind of this is a good entry level microcontroller for people that want to do wearables. And that's a kind of a fun field. So you actually get conductive thread that conducts electricity, and you sew these things into the fabric with the conductive thread, and then you can connect your sensors, you can connect the battery, it can be on Wi-Fi, so all kinds of fun capabilities there. If you want to Google search wearables, that's a really fun field to get into. But same thing, these guys both have an Arduino. This one's a little harder to work with. It's more just specialized for doing LEDs, but it is a full Arduino. You can actually write your own code for it. This one is a general purpose Arduino, just like anything else. And of course, the general purpose I/O pins are around the outside. So that's the world of Arduino and microcontrollers. All right, so let's move on to the actual kit that we want to talk about. This is the AIY voice kit, and as you can see, these are the parts out of the box. It's got a button. I think they call it an arcade button because it's like those big buttons on video games, on commercial video games. This is a speaker, obviously. Here's the Raspberry Pi Zero. This is something called in the Raspberry Pi world, it's called a hat, which means a small device that goes directly on top of the Raspberry Pi, and it increases the capability in a certain way. So as we'll see later on in this presentation, this one is capable of working with sound. It's very good at working with sound. So it has two microphones actually built right into the device itself. They're very small. They're on the left and right side, but it gives you the ability to pick up true stereo audio input. And it also drives the speaker, so there's obviously a small amplifier on there to be able to produce sound. So it's called a hat because it goes right on top of the Raspberry Pi, as we'll see. In the Arduino world, this is sometimes called a shield, and so there are all kinds of different shields. You can have shields that give you a liquid crystal display, sort of like a really low budget iPhone, but many different shields. If you look up shields on Amazon, shields for Arduino or hats for Raspberry Pi, you'll see there's all kinds of capabilities. So you just have to look at what kind of peripherals you want to work with, and you can probably find a shield or a hat that will do that. So that's what that is. It's kind of hard to see, but this is the SD card. As I said, it comes with the kit. It's already pre-programmed with the operating system on it, so it makes it a lot easier for people their first time out. As you get better, you'll probably code your own, and you might make your own versions of Raspbian that do specific things. But this is a great way to get started, very easily. And then at the bottom, you'll see the cardboard, which is for those of you who might remember, Google started the whole sort of cardboard trend with VR cardboard, which was a very low-cost way of making a basic VR headset, a virtual reality headset with a phone and this piece of cardboard. It was really a brilliant sort of breakthrough to say, let's get technology in the hands of people that don't have a lot of money and let them experiment and let them play with this technology. So this is taking the cardboard concept a little further and taking it into more sophisticated kind of applications. So you do need some tools, but very minimal. I just need a very fine screwdriver and a set of tweezers, makes it easier. So, but other than that, it's really just out of the box. Okay, this is a close-up of the Raspberry Pi Zero. Here you can see, as we talked about, the GPIO pins. This is the SD card reader. This is the CPU. Okay, that's the brains of the device. This has one serial port that is data and one serial port that is only for powering the device. That's the only way to power the device. We'll explain a little bit about that later. So that's the Raspberry Pi up close. Now this is what I was talking about with the idea of a hat. You can see this hat has access to those 40 pins. So it's got a connector to the 40 pins on the hat, and it connects directly into the connector on the bottom. So immediately this top board has access to all of the pins from the bottom board. And in the case of this first voice kit, when we're just sending sort of audio signals back and forth, that's enough. As we'll see later on with the Vision kit, we need an extra connector for higher speed data, for higher speed video data between the two. But this is the idea of a hat. It's almost always exactly the same size as the underlying CPU, and it might have an extra button on top for doing certain things. It might have some extra pins for other kinds of peripherals. But that's the idea of the hat. Actually, I think this is the video hat, not the audio hat. But anyway, that's the idea of a hat. Okay. So now this here. Yes.
I have just a quick question. On this audio hat, do you have like stack included in the kit to do stuff like source localization or beamforming? Like you have on Amazon Alexa to do like source localization, then you just turn the LEDs just to show where the voice is coming from?
That I don't know. I think it's very similar to the audio hat that you actually sent me information on a few months ago.
Okay.
I think it's the same kind of thing, but I'm not sure specifically.
Okay.
Okay. So this hat also has connectors. I don't know, maybe there's a second connector for a second speaker, but this particular kit only uses one. So at this stage in the project, you fold the cardboard according to the instructions, and you start to put the boards together, and you connect things. It's pretty straightforward. There's a close-up of the hat. In the case of Raspberry Pi Zero, sometimes they call it a bonnet. So you can see this is the voice bonnet. Later on, we'll see there's also the video bonnet. So that's that. There are extra peripherals here. Maybe for external microphones. I'm not sure, but definitely some capabilities. Okay, so then you put together the main box, and you connect. I talked about that big button on top. As I said, there's no soldering. This makes it very easy. They designed the kit with this harness that just sort of slides on. So you just follow the color scheme. This plugs right into the to the main board, and you can see the speaker slides down in there. And voila, this is what it looks like. Okay. So it takes about an hour to put together. It's fun. It's easy. And so I wanted to demo the actual box, but it's tough to do because you need to be able to log into it, which I'll show you how we log into these things. But I wasn't able to do it on the high security LAN here, and I wasn't able to do this presentation while my laptop's not on the same LAN. But I'll talk you through it, and the idea is that you have to get on here to set things up and run things and program things. But I'll talk about that in a minute, okay? But one other thing I wanted to show you, this is actually somebody in the hacker community immediately came out with a better version of the cardboard. So this is taking the exact, for an extra $20, you get a beautiful sort of clear case that, a little more rugged and very attractive version of the cardboard. So, there are peripherals that you can get as well if you want to sort of, pimp your vision kit or pimp your voice kit. So that's that. As far as powering these things, that is the one thing that's not included in the kit. This is on the right is a pretty standard Raspberry Pi power supply. It's just nothing but a little power supply going into a USB connector. It's important that it has, for some Raspberry Pis, you want to have something that has up to 2 amps, as this one does. You can power some Raspberry Pis if you're not doing anything too CPU intensive. You can power them right up a serial port, but usually that's not recommended. You don't want to damage your serial port by drawing too much current. So I usually recommend something like this. As an alternate, if you want to have your device be completely mobile, like if you can see this, you can just plug in the device to a little, one of these chargers. This works great. These things go a long time. It gives you all the power you need. It's a really nice, super cheap way of taking your project and making it battery powered and mobile. Okay, and here's the back of the box. You can see you still have some capabilities. They did allow access to 6 GPIO pins. So I think you have to understand they're trying to get you not to just put this thing together and run it. They want you to hack. They want you to expand. They want you to try different things. They want you to be creative. They want you to break some rules and innovate. So we've got 6 pins to expand. Obviously, if you want to go beyond that, there are more pins on the inside. But this is a nice way of having them right on the back. You could get a connector, and you could, as I said, you could hook this up to a motor that would, and then you could have a voice command to say, "Open your blinds." Likewise, you can, instead of using the internal speaker, you can send this to a full-blown stereo system if you want to really crank some music. Obviously, HDMI gives you access to full screen if you want it. As I said, this USB port is only for power. This one's for data and power. So if you want to connect up some other external peripherals, you've got that capability as well. So lots of possibilities here. Okay, so now here's the slightly tricky thing about working with the Raspberry Pi or any microcontroller. You want to get it. In the old days, you used to just hook it up to Ethernet, and that was that. But since we want all our devices to be mobile these days, you want to get it hooked up to use the Wi-Fi. And the way to do that traditionally, you can hook up a monitor, a keyboard, a mouse, and log on to the device that way. But Google has also innovated a really nice app. Unfortunately, it only works on Android right now. So, but it would be almost any Android. So you can even pick up. I don't know if you guys have access down there to really cheap Android phones. it can be 3 years, a model from 3 years ago that doesn't have a lot of capability, but it probably, as long as it runs Android, it can run this app. So you download the app, and the idea is you need to get onto the Raspberry Pi and get it onto the Wi-Fi. Okay, so this is kind of like a three-step process. First, so you're going to download this thing to your Android, and then you're going to run it on the Android, and it will just talk you through what you're doing. But what it's really doing is it's connecting via Bluetooth to the Raspberry Pi, which then says, it asks if it's okay to access the Wi-Fi network, and then you'd have to put in the Wi-Fi password if it's protected, as most are, and once that's done, then the Raspberry Pi will connect up to the network, and it will acquire an IP address. And then, as you can see in the screen here, this app very nicely tells you exactly what that IP address is. Okay, so this is a lot easier than the old way, which was hooking up monitor, keyboard, mouse to the Raspberry Pi. This makes it just much easier over Bluetooth to get in, give the Raspberry Pi some information in the form of the password to the network, and then it comes back and tells you the IP. Super handy. So it's a really nice app. So then once you have the IP address, then the next thing you're going to do is you're going to log onto it from any laptop, and you're just remotely going on it essentially as a terminal. So for anybody that only does GUI programming, it's time to learn the command line. This is sort of an essential part of Raspberry Pi hacking, and there are plenty of tutorials. It's not that hard. Try not to be intimidated by it, but it definitely takes a little getting used to if you've never done it. It's great if you know VIM. It's not essential, but it makes things a lot easier. But there are other tools you can use. You can certainly Google, getting onto my Raspberry Pi with other devices. I'm sure there are GUI versions as well. But for what most people do when they're working with this, they do exactly what you see on the screen here. You'll SSH to the Pi, which is the username at this IP address that we just learned about in the last screen. Okay, so once you do that, now you've got a terminal directly into that Raspberry Pi. It's got a password, which is always Raspberry, and the kit will guide you through that, but it's pretty straightforward. And then once you get on, then you'll see you can. That's where you do all your real work. In the case of these kits, they have standard examples that they'll have you just get up and running so that you can try things. In the case of the voice kit, it comes right out of the box with essentially Google Assistant. So for $50 and a little bit of time, you've got your own, sort of budgeted Alexa, but it's Google Voice, it's Google Assistant. So all the things that you expect out of Google Assistant, you've now built that into your Raspberry Pi version. So it's pretty cool. So right out of the gate, it comes up and it can do all the kinds of things that Google Assistant can do. You can check the weather. You can ask it the meaning of life. All kinds of things. But of course, if you're Roberto, you're going to immediately start to add extra capabilities. You're going to code extra commands into it. And I think that's where the fun really starts. You could start to make your device very customized, and not just the software. Obviously, we talked about the GPIO pin. So as I said, you can give it commands to drive the motors, which are opening and closing your blinds, or moving around a camera, or all kinds of things, right? So so that's the voice kit. Before I move on, any questions on that so far? No, all good? Okay. So next up is the vision kit. Which is very similar procedure, slightly more involved. This is a little more costly. This is $90 instead of $50. You can get these online. I'm pretty amazed that in America you can actually buy these at Target, which is like a common sort of household goods store. It's a very mainstream store, so it's odd. You're not going to kind of obscure, computer hacker stores in the city. You can actually pick this up anywhere, anywhere to Target. So it's pretty amazing. So the Vision Kit is $90. It's a little more, but as I said, it's all inclusive. It has the Raspberry Pi. It has the SD card. This is what the kit looks like. And here's the camera that comes with this. Is really tiny, as you can see by the guitar pick here. And yet this is, I believe, a 16 megapixel camera. So this is no slouch. This is, about as capable as a lot of phones. A lot of people, I'm sure it's the same hardware that's used in people's phones in many cases. But they've just broken it out onto this little board that's easy for you to work with. This specifically is called the Pi camera. And this goes for about $30, not much. So if you don't want to buy the whole kit, you could just get a Raspberry Pi Zero for $5 or $10. You could get this for $30, and without the kit and the cardboard and everything, but just the raw Raspberry Pi and the camera, you're looking at 40, maybe $50. So it's pretty amazing. Okay, here you see the ribbon cable. Because it's video, obviously it has a lot more input-output lines. So it has this little connector, which you sort of pull out and you stick the ribbon cable into it and you lock it into place, and it works really well. And you can see the backside of the video chip has of the video board has all kinds of extra processing chips. It's pretty amazing they can do this kind of thing for only $30. Okay, so then this is the cardboard starting to go together. This is sort of the inner board. The ribbon cable, you sort of wind it around. Here's the video hat. Here on the right, you can see there's an extra video cable that we didn't need on the voice kit, but this is because you've got video streaming back and forth between these two. So there was a lot higher output or higher bandwidth data going back and forth. So that's the idea there. It goes in the box. There you can see a button that's already wired into the box. And voila. There's a slot for the SD card that goes in here, the micro SD card. And this is the front of the camera. This is a small piezoelectric speaker. So a piezo speaker is not really high quality. It's more just for beeping. So, but it's got the piezo speaker, it's got the camera, and it's got a small LED so that you, like a good phone app or a laptop app, it tells you when you're being videoed, when you're being filmed. So that light comes on whenever the video is working. Okay. They also added, I think, a very nice little touch. There's actually a metal adapter for a tripod. So it's kind of a nice little touch. Makes this thing a little more capable. You can attach it to all kinds of things. that could be really useful with some of the applications that I'll talk about in a minute. So there are the two kits, and that's what they look like. Let me see. I guess the one other thing I wanted to do was to try to show, just to give you an example of the, let me see if I can do this. Okay, so this is something called, this is the camera now powered up, the Vision Kit powered up, and it's got something called a joy detector. So this is where the Raspberry Pi is starting to use some of Google's software. In some cases, you're going to use that software to call their APIs, and in some cases, you can embed the software directly onto the Pi itself. The SD card has like 8 gig of storage, so you can certainly put some pretty sophisticated software on that. There are some things that do voice recognition, text-to-speech, speech-to-text, that run directly on the Raspberry Pi. But some of the higher-end voice capabilities come not from doing it directly on the device, but from hooking into Google Cloud services. So for those that aren't aware, Google has a huge slew of services, of APIs that are available up in the cloud. If you're just experimenting, they're free. I think you have to give them a credit card, but they only charge you if you start to use these things for high data, for lots and lots of data output. They're pretty generous in letting you get started and prototype and try things without dinging you for a lot of money. And in any kind of low volume, the cost is nothing or very cheap. But the Google Cloud Platform, I would urge you to go online and look at some capabilities, some of the APIs that are available. Obviously, Google Maps was one of the first APIs many years ago that people started to play with and hack and add all kinds of capabilities to their websites. But there are tons of them. There are natural language processing APIs. There are obviously vision APIs, language translation APIs. One of them comes directly on the voice kit that we talked about. You can ask it to translate into any language and a phrase into any language, and it will. Machine learning, I think we talked about. The Google Assistant, as we talked about, is an API. So if you start to explore these, I think you'll be amazed at the capabilities. And I think that's very important to realize, that you're no longer writing stuff that will work on a completely embedded device in all cases. It won't always run right on the CPU right here. In many cases, you're working in conjunction with the software that's running on the Raspberry Pi, in conjunction with all of the APIs that are available to you through Google Cloud, or any API, right? There are hundreds of thousands of them out there. They're amazing capabilities, as many of you know, I'm sure. So this one is something, I don't know if this is going to show, but this is something called the joy detector. So it's basically looking at the camera is running, as you can see by the light that's on, okay? And it's looking for faces. So it's constantly interpreting the imagery and looking for faces. And when it sees faces, it will actually look to see if that face is smiling. And so the software that they sent as a sample constantly keeps looking for this, and when it sees you smiling, the LED on top of the button will glow yellow, and when it sees you frowning, it will turn to blue. So it's trying to look around the room and detect joy or happiness. So I'm going to first turn it on my face. You can see that it went blue, and then I'm going to smile, and I don't know if you could see that, but it turned yellow. Now I'm serious again, so it's going back to blue, and now I'm turning it away, and it goes off. So it's only on when it sees a face, like this, and then it's watching for my smile. And maybe I'm not sufficiently joyful. Oh, that's right. I think they said if you get too close, it doesn't work. And there it is. Okay, so a simple application, but I think you get the idea. You can write software that works both locally on the device and in conjunction with APIs up in the cloud. And many applications will combine 2 or 3 or 4 of these APIs for some very powerful combinations. As you've probably seen, for those of you that have gone to hackathons, you know how this works. There are amazing capabilities. So that's the Vision Kit. As far as the programming language, you can code for Raspberry Pi in just about anything. Most people, especially when you're starting out, code in Python. So if you haven't worked with Python before, it's a pretty easy language to pick up. It's a little quirky because it's tab-based rather than having more traditional code structures and brackets. But once you get used to that, it's like any other scripting language. It's like, not that different from JavaScript or Ruby, Perl, for those that go back. But anyway, I urge you to get one of these kits and try it and see what you can build. And I think that's it. Any questions?
Do you guys have any question? I have a question, Larry. Just
Shoot.
on the Vision algorithms that you can run locally, which ones have you tested that you have like good FPS, like face detection is running well on this kit, or which type of things can you run locally at a good frame rate? I'm not sure if face detect.
My guess would be if you wanted to run more sophisticated face detection, I would probably say you should bump up to a full-blown Raspberry Pi. The Pi Zero is a great way to get started, a great way to prototype. You can completely write your code on that, but it's a little slower, and it's only one CPU. So it didn't show up very well today, but in general, this face recognition has worked surprisingly well. I've worked a little bit with, it's also got an application where it identifies things. So you put a banana in front of it and it tells you that's a banana. You can put an apple in front of it. It'll actually tell you not just that it's an apple, but the kind of apple. And if you code this, you can have it, you can output to the display. If you can send the HDMI cable to a display, you can actually see the running real-time output of what it's interpreting. And what's really cool about it is it gives you a confidence coefficient. So if you give it something that looks a little bit like a banana, it'll say, I think that's a banana, but I'm only 50, 60% sure. Whereas if you put like a nice, beautiful yellow banana right in front of it, it'll say, that's a banana and I'm 95% sure. So,
Cool. So you have a
um,
debugging
so
interface for
for
that.
that, what's that?
You have a kind of a debugging
Sorry?
interface to.
Yes, yes, exactly, exactly. And of course, um, then you can build certain things in. You know, you could have it. I coded not on this kit, but on another Raspberry Pi a few months ago. I coded something that just said, uh, when you see something in the image that's and you're over, say, 80% confident, uh, send that to text to speech and and send that to a speaker. So you know you would put a banana in front of it, and it would if it was right in the right place and it was clear, it would say banana. And so it's a little spooky because you can put all kinds of different things. I think there are like 1,000 different objects that it gets right like almost all the time.
Cool.
So 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 it's this is really starting to get into the beginning of AI, right? To have this, little inexpensive robot that's driving around and looking at things and knows knows what it's looking at to some degree. It's crude, it's simple, but you could certainly have it, drive around a room and look for a banana, and when it finds it, stop and tell you, "I found the banana." You know,
Yeah, or a
um,
dog or a cat, something
so
like that, right?
or a dog or a cat, which it's also very good at identifying. Uh, yeah, you could have it follow the dog. Um, so yeah, a lot of pretty crazy capabilities. Um, you can
Uh,
also, if you Google AIY Vision Kit, you can already see that this hasn't been out that long, but the the maker community out there has already put up all kinds of crazy projects of things that people are doing with these. So
yeah, it's great. Yeah.
pretty amazing. It's a great platform for getting a whole new, because it's so inexpensive, for getting a whole new uh, group of hackers and makers sort of into this space, into this you know software space, and hopefully getting them to start to code Python. And for the software developers, I'm sure some of yourselves included, this is a chance to get your hands dirty with hardware. That's, I think, the real beauty of this is, I mean, I work with a lot of software people that have never touched a Raspberry Pi. So this is a great way to get in and use your software skills to do some cool things in hardware. And the intersection between hardware and software is where I think all the fun is, because there's so many capabilities right now at this time. Um, sort of a golden age for inventors and makers and hackers, because the hardware capabilities and the software capabilities, and now just the beginning of artificial intelligence capabilities um, combined, you can do some amazing things.
Nice. Have you played with this? There's one GPU from Intel called Movidius. Have you played with that?
With which one?
It's called Movidius. It's a GPU on a stick. Let me.
No,
I
huh?
Yeah, I'll paste everybody here. Something that maybe it's a good add-on to the video kit that you just showed us. This
Huh.
is a
Uh-huh.
it's a startup that was bought by Intel a few months ago, and they have this GPU on a stick. So it's a USB pen drive GPU, and you can plug that on a Raspberry Pi. So it help you to do most of the local stuff locally on the Raspberry Pi instead of. But this is maybe a nice add-on to the Vision kit that you're showing.
Oh, interesting.
Yeah, it's
Huh.
kind of costly. It's like 80 bucks, but with
Uh-huh.
this you can like do drones or stuff that doesn't rely on a connection to do detection stuff. It's pretty nice stuff.
Oh, okay. Oh, that's cool.
And yeah, it
Yeah,
took
I
some.
was.
took some time to integrate with the Pi, but now I think it's almost fully integrated. People can do this on Pi already.
Uh-huh. Yeah, I guess you just download a library and then
Yeah.
pull it in.
Yeah.
Yeah, that is nice. A lot of these hardware peripherals for all the people that are hacking on Raspberry Pis, a
Yeah.
lot of them come with libraries that you just sort of pull off the shelf and you can code them pretty easily.
Yeah. It's plug and
Um,
play.
yeah, I was thinking of sometimes my dog is pretty good, but sometimes I dog sit for another dog, and whenever he comes over, he's always like getting into like the cat food, and he's always doing some mischief. So I thought you could probably take one of these and put a motion detector on the front of it, and because I don't want to watch, 24 hours of footage, but I could put it right by where he's doing all this crazy stuff, and just have it as soon as the motion detector starts, you could kick it off,
Yeah.
and you could, of course, even send it to me at work while it's going on. Uh-oh, the dog's, wreaking havoc. Um, but I also thought it'd be nice. You could also very easily do like a time lapse. You could set this thing on the tripod, put it in front of a plant that's growing, or maybe a big event. Maybe I was thinking for my Maker Faire, if I wanted to get a time lapse of the whole day of everybody moving around and all the activity, you could take one of these and just write a simple program that would say, take a still every minute or every 30 seconds, and you could have it go for a while, and then crank out a nice little time lapse video. Uh, Things like that. It's nice to do with your phone, but who can put down their phone for 24 hours?
Yeah.
We need them
Yeah.
too much.
Sure.
So
Yeah.
so those are just two of the projects that I want to do.
Yeah, and then
This
maybe
kit.
share with us later the time lapse then.
Yeah. Right. That sounds good. Or the videos of my dog getting into trouble.
Cool. Do you guys have on the line, do you have any other question to Larry? Oh,
Okay, how many people are going to try one of these?
yeah, maybe, I think people are always going to Jersey or to Alpharetta. At least for us, it's a good time to get one of these. Because for
Uh-huh.
us, here's a lot of
Yeah.
taxes that we put on top, so it's always a good gift
Yeah.
to make itself.
Yeah. Well, if I don't know what the availability of these kits is down there, but certainly if anybody, if you can't get them down there, let me know. I can certainly send some down. If,
Perfect.
happy to do that. If you can't get them yet down there, I'm guessing you can, but happy to help out if you need help getting hardware.
Perfect. Oof. Thanks.
Okay.
So if nobody has any question, thanks, Larry. That was really
Okay.
fun. Yeah. Yeah, and I'm also
Okay.
happy to see this type of talks here, like hacking stuff or making stuff that's
Hmm.
not really payroll. It's always
Uh-huh.
maybe nice to do something a bit different. Maybe we find some overlap that we can,
Uh-huh.
but who knows, right?
Yeah, who knows? Who knows? That's the nature of an innovation lab, right?
Uh, cool.
Okay. Well, thanks for listening, everybody.
Thanks, Larry. Have a nice day.
Okay, sounds good. All right.
Thank you, man.
Bye.
Bye bye.